Welcome to this next tutorial on VB Express, which is going to introduce the concept of random numbers. So we're going to go start a new program now. I'll just call it Random Numbers as my new name. And with this one here, we're going to use two different ways of creating random numbers. One of which was the old way, and now we're going to use also the new .NET method, which VB and C# can both utilize. So with a random number, the way that it works is that when we have games that we want to try and make something a little bit more challenging, where the user, such as is trying to guess a random number, we obviously don't want the same sequence of numbers occurring every single time, because it would become pretty easy to try and guess. So unless you're wanting to make a multiplayer game where two people play off against each other, we're probably wanting to involve the computer in some way. So computers, as you should probably be aware, are not random. They can only pretend to be random, and they do a pretty good job of it with a bunch of different features and functions that are built into the language, and I'm going to show a couple of those now. So with this new program, first off, let's show you how we can make a new random number. So to start with, I'm going to have a variable which is going to remember a random number that is going to be created. So a random number of, say, between 1 and 10. Now, to do that, I'm going to show you the old method to begin with. So we've got this data type for rand1 that's going to be holding our random, and I'm just going to write out the method here to begin with, and just bear with me here a little bit because it may look a little bit confusing to start with, but I'll go through and explain it from there. And it helps to work out a little bit of the logic of how this actually might occur. So what you can see above this console.writeline code that I'm writing is the fact that we've got this rand1 is equal to int, and we've got this rnd line or statement that is actually making a random number. Okay, and I'll go through and run the code here so you can actually see how this will be built up to work. Okay, so to start with, let's go through and see what RND actually generates, shall we? Okay, so RND by itself makes a random number that is very, very small. It's going to make a random number between 0 and 0.99999 recurring. So it's a small number between 0 and not quite 1. That's what RND does. Okay, so RND makes a number between 0 and not quite 1. Then what I went through and did was I multiplied it by the upper range of the random number that I'd like to go up to. So for instance, if I'd like it to go up to 10, I did this. So if we have a small number, say 0.9999 being made by RND, we multiply that by 10, that'll end up as being equal to 9.99999. Okay, so hopefully you're with me so far. Okay, so RND times 10 is going to end up with this little number here of, say, it generated 0.9999 recurring, multiplied by 10, 9.9999. Now, we actually want this to be held as an integer. So what we're going to do now is we're going to convert or cast this number temporarily. That's where you change the value of these things here, of what's inside the brackets, into an integer. Okay, so that's what this three-letter code does. It converts whatever was made here, which in this case would be something called a float, or a decimal number with some numbers after the decimal point. We're going to convert all of this stuff here that's inside the brackets, and BEDMAS does apply here, so it's going to work through in a logical order inside of the brackets first, and then it will convert it all into an integer. Okay, so if it was actually making all of that into 9.99999, make it into an integer, you probably think that it would round up to 10, but that's not the way int works. What it does is it will round everything down and make it into a whole number. So it's going to truncate and round things down. So even though it's 99999 at the end there, it's actually going to round the number down to be 9 at the end of all of this. Okay, so this is actually going to make a number theoretically between 0 and 9. Even though it says 10 there, the way the random numbers are generated is actually always never going to hit 10. So if we were to go through and try and test this now, and then see how this might work. You'll notice that we've got the first random number occurring, which is a 7. This is a great example of how we might want to wrap this statement here in a loop. Okay, so what I'm going to do here now is I'm going to do, say, a counted loop of 1 to 100, and I'll pop down the bottom here, oops, and just put in next. So these lines of code here are going to get repeated 100 times, and then once it's written all of the 100 random numbers to the page, it will do the console.read line. So if we go through and run that now, okay, here's our big long list of numbers, and I'll just go back up to the top here. So 752, etc. We've got a 0 in there. One thing you might notice when I scroll down the page, there is no 10 being generated. Okay, but there is lots of zeros. So that last bit of code that I had up there before was +1. And what that does is it means that it no longer goes from 0 to 9 anymore, it will now go from 1 all the way up to 10. Okay, so that's a method that you can use to try and create the random number. If I go through and rerun this program now, okay, you can see we've got some 10s in there, we don't have any zeros. One thing I'd like to show you now is I'm just going to make this perhaps a little bit more obvious. I'm going to only do this 5 times, we'll make 5 random numbers. Okay, so here are our 5 random numbers working, and you might think, yep, great, that's fantastic, it's doing what it needs to do. But let's see if we can remember these random numbers and the order in which they're made. So it's made 8, 6, 6, 3 and 4. Going to close the program, going to rerun the program, and it's made the same sequence of random numbers, which we obviously don't want. So what we need to do using this method is something called seeding, and that is where we tell the computer that yes, you can make a random number, but we need to change or mix up the starting number that you begin with. And the way that we do that is we simply use a word called randomize at the start of our code. We only need to use this statement one time when the program is running, but because we're using a console and just a simple main procedure, we'll just do this one time towards the very top. Okay, so now when we run the program, you'll notice that it's a different sequence of random numbers that's going to occur each time. The way that it manages to do that is by using the milliseconds that occurs on the clock. So down the bottom right hand corner where it says the time, the milliseconds which you don't see ticking over, it does some freaky deaky calculation with that, whereby it will then come up with a randomly assigned starting point. Okay, which is why you'll never see the same sequence. Computers aren't truly random, however, and there is a way to crack those kind of codes, but for most of the types of applications that you and I will build, that method is certainly fine. So that's the first method for going through and creating a random number. A way that is perhaps a little bit more elegant and newer now is we actually can use a random class of object which gets created. So again, I'm going to try and comment that code there out. I'll use the same variable which is going to remember temporarily once the random has been made, and what I'm going to do here now is I'm going to make this random number occur. Okay, so I can't really use the word random because it's a key word. Okay, so I'm going to need to try and come up with something a little bit more logical than this. Okay, so I'm going to call it dim. I'll just call it ran. Okay, and the way that we can declare and work with a new random is we'd say dim ran as new random, remembering that ran is going to be the temporary name of the information that'll be remembering what the random class is going to be. Okay, so either way, one of these methods here is acceptable to use in the likes of the assessment, which will require the use of randoms. It's just whichever one you prefer the most. Now, the bit that we need to try and work with now is we now need to tell it to generate the random number, similar to what we've done up here, where we need to tell it the limits in which we need to work with. With this method that I'm about to show you, we don't need to use this randomize statement anymore. It's already built in, it's smart enough to know what it needs to do. So we're going to use this random1 variable to remember what this random object gets generated as. Okay, so the way that we do this is we say, let's use this random object and then we push the dot property. By doing that now, you can see a bunch of different objects that will occur, and one of which is going to be the next method. Okay, so the next method is going to make the next random number, and then it's going to assign this into my rand1. Now, if we go through and try and run this program now, it actually hasn't worked because what we need to do is then output this rand1 back to our console. So we'll do that now. Okay, and now when we try and run the program, this rand1 will appear in our console window. So you can see that when we try and run this the first time, it ends up with a really large number. So we don't have the same problem up the top here with making small numbers. It makes really big numbers. If we try and rerun the program, you'll notice that it's a different number that occurs. So we do get the randomness, but the numbers are too large for us to really work with. So one of the ways that we can try and change that is inside of these brackets here. You notice when I put the first bracket, this little box here occurs, and what it is going to be doing without information inside of these parentheses or brackets means that it's just going to make a non-negative random number, and it's quite a large number. So if we're wanting to put some more information in here, we use these things called overloads, and that's where we tell the program some more information or constraints that it'd like to work with. You might notice it says 1 of 3. If I click on the down arrow, it will tell me the syntax or the way that I can write things. So what we've got here is max value as integer. So what it's saying here is it wants an integer to be typed in, which is going to give us the maximum number that will get created by this .next method. So for instance, if I was to type in 10 as a random number, as an overload, what would actually occur is it would make a random number between 0 and 9. Remember that it's not going to make the number of 10, and that is because of the same situation as we had at the top there, is that it will still do this whole same process of making a small number, doing the multiplication, and then rounding things down. So if I wanted to make a random number of 10, I would then need to also do that tacking on of 1. Okay, so let me just show an example of this. So we'll do a for counter equals let's do 1 to 100. And then at the end of all of that, we'll go through, plug in the next, and then if we run this, we can just see the situation occurring like I've just mentioned, that we're getting zeros, but we don't get any 10s popping up. Okay, so if you want to have a number between that goes all the way up to 10, we're going to plug in the highest number possible plus 1. So this is going to make a number all the way up to 10 now. Okay, so if we try and rerun this code, you'll notice that we've got 10s, but there's one other thing that we have. We've got these numbers zeros occurring, which we don't want. So I want a random number between 1 and 10 to occur, not 0. So the last thing that we can do here is going in this, we can actually plug in some more information. So you'll notice that this is 2 of 3. If I click on the down arrow, we can also do min value as integer and max value as integer. So if we don't need to use that box, we can just plug in our lowest number and then our highest number plus 1. Okay, so 1 to 10 is the random number that will be made using this new method. And we can quickly verify and check that. When we scroll through this list here, there's our 10s, you can see we've got our 1s, so there's our program working as expected. Okay, so that's how we can go through and make a random number. One of the examples that I think is quite fun is when we try and do like guess my number type games, such as I'm thinking of a number between 1 and 100 and you try and figure out what that number is. So most people, when they are presented with a problem like that, they'd actually use a classic searching method where they might say 50 or a number pretty close to the halfway point of that range. So you're actually thinking really well in terms of a searching method. You wouldn't start at say number 1 to start with, because that gives you 99 other choices. Whereas if I was to say 50 and then if I was the person trying to know that random number, I'd say higher or lower. That means by guessing 50 you've eliminated half of the choices straight away. So if you guess 50 and I say that it's higher, you've automatically not going to guess any number that is less than 50 anymore. You'll start guessing 65, 95s, etc., and I can keep saying higher or lower. So we're going to go through and develop a program now that will look something like that. So here is an example of something called a flowchart, which is going to express the logic of my program using a pictorial or diagram format. It's quite good when you're programming to try and have a bit of a written plan of how you might try and approach this problem rather than actually just jumping into things. So this is a classical way of actually thinking about the logic before you actually start coding things up. Most of the problems and programs that we're going to make, however, are relatively straightforward, and for the assessment you won't need to do this. I'll present you with some kind of diagram or way of coding the program, but I'd just like to spend a couple of minutes explaining this. What we've got here with the flowchart is something called these start and endpoints, and any program that you make using a flowchart will need to have these two symbols, which starts and ends it. A flowchart will only have two of these. They're called terminators, and they begin and finish the program. When you design a flowchart and work through a flowchart, you're generally trying to work top to bottom and left to right, just like how we're taught to read. So we don't want to have boxes going left and right and where possible, because that makes things a little bit more confusing. These little rectangles that you can see there represent a process. So after the program starts, we're going to have a variable which is going to remember, to start with, will be initialized with a couple of zeros. Okay, so here's another rand, which is also going to remember 0. Rand is equal to a random number between 1 and 10. That's obviously not how I write the code, and there's a good reason for that. This is more like something called pseudocode, where it's not quite programming language, but it can be interpreted into any programming language possible. Just the syntax or the way that you write things will be different. So for instance, for this, what we're saying is make a random number. How you do that in your program language is up to you and the language that you're working with. With this parallelogram that you can see now, this is actually a message or a display that gets shown to the user. In this case, it's saying display the random number on the form for testing purposes. So for this situation, we actually want to show what the random number is just while we're testing, so that the person we can work it through to make sure things are working correctly. We're then going to ask the person to type in a number, and then we're going to go through and do some decision making checking. So when you're wanting to display some information and get some information, we use these parallelograms or pushed over rectangles to try and do that. This item here is a diamond, and this represents a decision or if statement in our program. And we often will structure this with using if, or we can say is, and we can sometimes use true or false. In this case, I've used yes or no. So we're saying, is the user input a number? And there are only one of two choices for that. Either yes is a number or no it's not. If it's not, we're going to display a message to the person, and then it's going to pop all the way down towards the bottom, and then in this case it's going to end. You might notice that this program here does not have a loop occurring in it. Okay, so that would be something that we might decide in terms of making an enhancement, is to demonstrate a loop. Okay, so if they have typed in a valid number, it's going to pop down towards the bottom there, and then it's going to remember that information. So we might decide to put in try catches or some other error checking method. It's not really clear from this diagram if that's occurring or not. We're then going to go through and work out if the guess is considered larger than 1 or less than 10. Okay, so for instance, if a person guesses a number that's too small, we're going to go through and check things out. Okay, and down towards the bottom here, it then works out whether the person's guess is correct or not. Alright, so to make this random number game, we're going to go through and just comment some of the stuff here out, and it's going to have a fair bit to it, this particular program, so I'll give myself a bit of space, and we're going to start using some of these concepts here. Alright, so when we start designing a bigger program like this, you've got to think about the things you can do easily to begin with, and some of the things that we've already talked about previously is about good commenting. So let's go through and write in a couple of those things that we talked about. So the author of the program, put your name across the top of the page there perhaps, date that you created the program, which in my case is going to be the 11th of the 5th, 14th, and the purpose of the program is going to be a guess by number game. So Okay, so some basic comments going through there. And then we're going to go through and declare all our variables. In this case, we need to have a little bit of a think about our problem and what it might need to be remembering. So what we want to try and do is, one, remember a random number, and secondly, we need to be remembering the person's guess that they type in. And then if we're wanting to do a loop, we need some kind of counter or boolean which is going to keep remembering whether they've guessed the number correctly or not. So that's at least 3 variables that we're going to need, possibly some more as we get into the program. So the first one that we're going to go through and do is we're going to try and remember what the person has typed in. Now we want that item that they've typed in to be an integer, and I'll go through and declare that as well and initialize it with a 0. The next one that we're wanting to try and do is I'm going to try and use a variable random to guess as integer. Okay, so this is going to be the variable that will remember what the random is that the computer generates. Okay, and then lastly, I'm going to create my random number using that method that I showed you before. So I'm going to make a new random like so, and then the next method I'm going to do is I'm going to go through, generate my random to guess. Oh, that's not right. Random to guess is equal to our rand.next, and depending on the random number that we'd like to try and generate, I'm going to try and do between 1 and 10 to start with. So once we get the logic of our program working correctly, then we can try and extrapolate that up or take that concept and make it bigger. So we can make it up to 1 to 1,000 or 1 to 1,000,000 if we wanted to, and just keep going through the guesses. But 1 to 10 is a pretty small range of numbers for us to work with to begin with, so that's going to be quite tidy for us to try and deal with. Alright, so that's going to generate the random number. Now we're going to ask the person to type in their details. So let's go through and ask the console.writeLine. Okay, please type in a number between 1 and 10. And then we need to go through and remember what they've actually plugged in, don't we? So after that, we're going to be remembering what they type in through user guess is equal to what the user types into the console. Alright, then we'd go through and do some kind of conditional check. We're going to go through and check to see whether the user guess is equal to the random guess. And if it is, that means they've guessed correctly. Okay, so then congratulations, you've gained it. You've done it. And then I would do some kind of pause at the bottom here. Now chances are it's going to take a little bit more time to guess the correct answer here. So this is where we're going to use a bunch of else ifs to try and work this through. So if the user guess is going to be greater than, put that in, if the user guess is greater than random to guess, we're going to say that it's too high. Okay, so if it generates a random number, say of 5, and they type in a number that's bigger than 5, we want to tell them a line of code which says too high, try again. Okay, and if they guess a number that's smaller than that, we're going to say too low. So if, and this is the bit that you've got to be careful if you're going to copy and paste code, we need to be smart enough to now alter that symbol the other way. So if the user guess of say they type in 2 and the random to guess is 5, okay, they've guessed too low. Try again. Okay. Another thing that we might decide to do is actually a little bit of boundary checking, because what if they go through and type in a number that's outside of the acceptable range? Acceptable range, remember, is between 1 and 10. In this case, it needs to be 1 and 11, doesn't it, because of those problems that we had earlier. So that's going to make our random between 1 and 10, whereas before, which I had 1 and 10, would do between 1 and 9. Okay, so let's change that back to 1 and 11, and there we go. So we're going to say too high, too low, or congratulations. Now you might think, why don't we come down towards the bottom here, else if. Okay, else if the user guess is greater than random, let's just say the upper number. Okay, let's do that. Okay, so we could go through and use this situation here. Okay, and I could say there, please type in impossible. Please type in a number between 1 and 10. Okay, and then if we were to try and do the other situation of another else if, we could say if they type in a number that is less than 1. As you might have seen in some of those other tutorials though, because of this generic statement, I'm just going to try and replace that with an or statement. And this is going to take care of both situations. So if user guess is less than 1, then that's also considered impossible. So if they type a number that's too high, too low, it's going to go through and do this. We can go through and test that program now and see how things are working. So if they type in a number, say, of 11, is it going to go through and do what we need it to do? No, we have a bit of a problem. I'm missing off a bit of code there, aren't I? Okay, so I need to plug in the console part. Another problem with copying and pasting a code. If you copy and paste some code that's no good, such as that one there, I've just duplicated the same problem a number of times. Okay, so let's see if we can try that one more time. Another message that's popping up. Nope. Okay, so let's try that again. So we'll type in 11, too high, try again. Okay, so let's have a look at that logic there. We want it to actually say that it's considered too high. Okay, in fact we want to say it's impossible. Okay, remember the problem that we've got here is the item of sequence. Okay, you might think, well, there's our problem there, that should be jumping down to this. But as soon as we do this situation, we type in 200, this condition is met, which means that it's never going to trigger this code down here. So in terms of sequence, we need to be altering this slightly, bringing this high up in our code, and then changing this to an else if statement so that we're able to take care of that situation. So if they type in to start with a number that's outside of our acceptable range, it will do this line of code, otherwise it will pop down towards the bottom there. Okay, so if we now try that same situation, okay, we get that error message like we'd expect. Remember, the other problem that we could have is if they type in something that's not valid, such as a letter, that's also going to damage the program. We want to try and use that try catch statement to try and make this work better. So the part of the code that's going to give us the problems is this line of code here, because user guess is supposed to be an integer. When they type in a letter, it can't deal with that, which is where the problem occurs. So if we use that statement of try, it's going to try and jam what they've typed into from the console into this variable. If it can't do that, let's pop down towards the bottom and let's do this catch statement with the end try at the very bottom. Okay, so what do we want to try and say? We're going to try and say to the console, gosh, spelling's not so good tonight. Okay, please type in numbers only. Okay, and again I probably want to try and bring this outside of my statements because I need to repeat it one time. Okay, so now when we try and run the program, they type in a letter, the program can handle that. Okay, if I can plug in numbers that are too large, it can handle that. If I type in numbers too low, they can handle that. And also if I go through and try and create the program, it will work as well. Okay, so there's our program in a nutshell. We've got some other things to try and expand upon this now. So for instance, we're going to want to try and now build in some loops to this so that it's actually going to keep asking the question. Let's go through and just check out to see what our program does when it works correctly by putting a breakpoint. in order to do this on the first instance, if we try and cheat a little bit, we're going to work out what our random number is to begin with. So for instance, our random number to begin with is going to be 7. So we know how to cheat with this program now. When it pops up, we're going to try and type in 7, and it should be popping up into our code and saying that we've guessed it correctly. So let's see if that actually occurs. Okay, so congratulations, yes, we have got the correct thing. Okay, so let's go through now and work out whether we'd like to try and continue with the program. One of the things that we can do here is that we can either do one of a couple of things. We can continually run the program again and again and again until they've guessed correctly, or we could pop up and ask the person to see whether they'd like to play a game. So let's maybe try and do the two together, starting with the simpler item. Okay, so we're going to need a Boolean variable for this one here. Okay, so dim player game, for instance, as Boolean. And to start with, we're going to say true to begin with. Okay, and then I might have another Boolean which I might use to start with. And I'm going to call this one here got it. This is if they've guessed it correctly to begin with. Okay, so to begin with, I'm going to set this one to false. That means that the bit of code here is going to keep going until they actually guess the random number correctly. Alright, so while got it is equal to false, which means that they haven't guessed the correct number, I'd like the program to keep going. Okay, so while got is equal to false, remember the problem that we've got here is that we must end it. So we're going to do that at the very bottom so that all of this code gets repeated again and again. Let's go through and run this program. And it looks pretty good here at the moment, but there is one problem or error that you might try and work out from this code once it's going. Alright, so if we type in, say, our number, okay, please try again. Okay, so we type in our next number. Okay, so here it is, impossible, working, letters, it's able to deal with that. Okay, so let's try seeing if this works. Let's try all the numbers and see how this works. The problem that we've got is that it's actually gone through all of the numbers and we haven't guessed it correctly. And the reason why we have a problem is because of where we've put this line of code here. By placing it inside of the loop, every time it goes through the loop, it regenerates a new random number. So that makes the game really hard to win. So we're going to take that and we're going to drag it outside of our loop. Need to stop the program and then redo that. Okay, so it was working before, but it was making the game really hard by remaking the random number every single time. So again, that's the concept of sequence. Where you place things in your code makes a big difference. So now what happens is that this random number gets created, but only one time. So when we come into the loop now, I've got a better chance of guessing things. So again, if I was to start at the bottom, too low, too high. Okay, so something's still not quite right with this particular program. Okay, so if I type in 7, too high, 6, too high, 5, too high, 4, too high, 3, congratulations. The reason why it appeared that there was a bit of a problem is because of the way that we've got two console.read lines causing these pauses. Okay, so for instance, after I typed in 0, the correct message popped up, but then it said please type a number between 1 and 10. A pause was given, which basically just required me to push the return button before it actually asked the question again towards the top there. So different ways of trying to approach that. Could actually remove this out now because the pause is going to occur when it goes back up towards the top. Okay, so by removing this console.read line here, it's going to work to a fashion until they actually get the correct answer. Okay, so for instance now when we try it, does the too low try again, then it pops straight up towards the top there and it's going to re-ask the question. Okay, so let's try that now. So too low, 7, too low, 8, 9, 10. Okay, 10, we actually don't want this next thing to keep repeating, isn't it? So they've guessed it correctly. If we wanted to rerun the next program, okay, we want the loop to finish, isn't it? So we want it to say congratulations. We're going to make this got it loop alter. So after congratulations, we're going to say got it is equal to true. This now means that the loop will then finish. Okay. The problem with that is that when we have the correct answer, there is no console.read line, because this is where the read line's occurring, which is not after this, after it's been guessed. So for instance, go through and type in the correct question. We get 6. We actually don't see the correct congratulations method or message. So I'm actually going to do a console.read line in here as well. There are different ways of approaching that. That's kind of a situation that'll need to be thought about when you actually are presented with these problems. Okay, so there's our pause occurring with this line here, and then the program will finish. The next thing that we want to do is, after they've actually guessed it, remember that it's going to pop out the bottom of this, and then want to continue through. Another thing that we can do here is we can actually ask the question of if they'd like to continue or not. Play again is equal to boolean. Okay, so we're going to do either another loop, or we can actually ask the question in here which says just change got it back to false. Okay, so here what we can do here is say response. I'm going to remember what the person's typing in now. Dim response as string. So I'm going to remember what they type in. Okay, so I'm going to say congratulations, would you like to play again? And it's good practice here to actually show how the person's supposed to type things in. So in this case they're supposed to type in either yes or no. You could do Y or N. You could do true or false. So providing a little bit of guidance to the user of how they're supposed to type things in. And then we're going to remember what they type in by using the response variable. And because we've said all lowercase here, I'm going to use that to string method, which is going to convert things to all lowercase, okay, to now work things out. Another thing that we could have done here is if they've actually got it equals true, which is going to make it continue on, we could do a little check here. Okay, so if response is equal to yes, then we could actually make got it is equal to false, which means that it thinks that the loop has not actually finished. It's going to continue on with things. Okay. If we don't choose to do that, we can actually decide to change the got it to true. Okay, so you'll notice now that we've got an if inside of this other if statement. Remember, that's called nesting. This situation here is only going to be looked at if they've actually guessed the correct random number. So let's go through and check this out to see whether it's worked or not. Okay, so if they type in the number, too high, congratulations, would you like to try again? Yes. It's now going to alter this got it back to be false. Okay, and the game starts again. Okay, a couple of other little problems that we've got with this is that it is actually still going to be the same random number. So this is where a little bit of problem solving and troubleshooting needs to come in. One of the things that you can try and do with this is that you could regenerate a new random number after they've actually got it correctly. Okay, so you could generate a new random number inside of this statement here. Okay, so if we were to try this now, 5, too low, too high, 8, correct, would you like to play again? Yes. Let's try it again with 8, too high. So there you can see our random number is now regenerated. Too high, congratulations, would you like to play again? No. The program finishes. Okay, so that's one way of doing it. Another way of doing it was the original way I was going to show, and that is by using the play again as a boolean. So that method actually uses nested loops. Okay, so we're going to say here, while play again, is equal to true. I'm going to keep playing this whole game, and we're going to take this end while and place it at the very, very bottom. Okay, and with this one here, we're going to be working out whether we'd like to play again or not. So if response is equal to yes, they would like to play again, okay, we're going to make sure that that's set to true. Okay, so play again is equal to true. Okay, and then the other way of doing it is where we actually try and work out play again is equal to false. Okay, so in this situation they are not wanting to play again, which would change this outer loop. So now we've got an inner loop and an outer loop. Okay, so it depends on the way of thinking that suits you best. This is also going to solve the problem like we just had before. Okay, so too low, too high, 6, would you like to play again? Yes, there we go, our numbers regenerated using this situation here. Okay, so please type in a random number. Too high, too low, too low. Congratulations. Would you like to play again? Because I didn't type anything in, it just assumes it's going to be okay. One other way using this new method that I've got is that I don't need to do this again. I can simply go through and change the location where I've placed this random number in here. Okay, so there's our program pretty much working correctly. There's a fair bit to it. You notice that's got some good error checking in there. We've got these nested loops going through. We've got conditional statements. We've got a good range of variables being used. The last thing for the standard is to actually show that you've done good testing on the program. So for instance, testing for achieve means that your program will work on things that are expected. So these are the numbers that are considered expected for your program. If your program can work with that and work correctly, that means that you're working for achieved. If your program can deal with boundary data, it needs to be able to deal with numbers that are around the fringes of what's acceptable. So for instance, 0 should not be allowed. We're saying it's impossible. 11 is another number which is considered impossible. And then lastly, we need to be able to deal with numbers that are not expected for excellence. That are things like letters. The program should be able to deal with that and not give an error message other than one that's been nicely coded in there. Things like special characters, etc. should be allowed to be run in the program and not kill the program. In terms of testing for efficiency, going through and testing on every single different variation is not efficient. A better variation or way of being able to present that is by simply going through and testing on critical boundaries. So for instance, to show that I'm working at achieved, I could go through and type in 1 to 10, but if I'm wanting to go for excellence, I would probably want to go through and show that my program can deal with 1 unexpected data, and then for merit I need to go through and show that my program can deal with the 2 outer boundaries. That doesn't mean I need to test on 12, 13, 14. Again, that is not efficient. I simply need to test around the fringes in the most efficient way possible. And then lastly, I could go through and show that my program can work on things that are inefficient. And in this case, I guess the number correctly first off. I can type in yes, the program's going to go again. I'm working on numbers that are expected. Okay, so too high, congratulations, and no. Okay, so here's a situation of my program now doing all the things it needs to do. Okay, and in terms of me being able to provide evidence of that, what I would do is take a screenshot or a screen dump by pushing the print screen button, going into a new Word document, and then pasting that print screen in there, cropping that information down so that it can be seen clearly, resizing, placing your name in the header, okay, printing that off, and that shows that you've tested the program and that your program works on all of the different boundaries, unexpected and expected data, which is going to be working towards excellence. So I've hoped you found these tutorials helpful. Pretty much that's going to cover all the level 1 material that you need. Look at the console introduction booklet that I've developed to try and help support you. There's a few extra things in there which I haven't covered in these tutorials that are very helpful, such as things like isNumeric and len, and some of these other items such as case statements. There's lots of good stuff in there to try and help support you. Remember, if you are feeling a little bit overwhelmed with any of this materials, that we often run tutorials at school, and it's really good to take advantage of those to try and help best prepare for these tutorials. So the best of luck, boys, and good luck for your upcoming assessment in this.